an important relation or important law that gives a relation between potential applied across a conductor and the current flowing through it is known as Ohm's law. And Ohm's law states that the potential drop or the voltage across a current carrying conductor is directly proportional to current flowing through the conductor. So if V is the potential difference applied across a conductor, then it is proportional to current flowing through the conductor, or V is equal to Ri, where R is a constant of proportionality known as the resistance of the conductor. So here from this relation it is clear that voltage varies linearly with the current. So if we draw the graph, then you can get V and I varies linearly, and so the graph is a straight line starting from the origin. Now R is a resistance. As the term itself suggests, resistance is nothing but it's a kind of opposition. It is an opposition given by a conductor to the flow of current, and that is the property of every conductor. And for each conductor, the value of resistance will be different. And R is equal to V by I. We can write R is equal to V by I from this relation, where V is the voltage, I is the current, and the unit of voltage is V is volt, current is ampere. So the unit of resistance is volt per ampere, or it is known as ohm, denoted by this Greek letter ohm. So the unit of resistance is volt per ampere, or ohm. And again, when current flows through any conductor, it gives an opposition. That resistance, that opposition given by the conductor is known as the resistance. And again, the resistance of a conductor depends upon R proportional to length of the conductor. As the length increases, resistance also will increase. R proportional to 1 by A, that is, resistance of a conductor depends inversely on the area of cross section. And one more factor is there, that is, resistance of the conductor depends upon nature of the material. Nature of material. And if we combine first these two relations, we will get R proportional to L by A, or R is equal to rho L by A, where rho is also again another constant of proportionality known as resistivity. So resistivity is the property of every material that depends upon the nature of the material. R is equal to rho L by A. If L is equal to 1 meter and A is equal to 1 meter square, then R is equal to rho. That means the resistivity of any material can be defined as the resistance if the length is 1 meter and area of cross section is 1 meter square. That means resistivity of a material is equal to resistivity of a material of unit length and unit area of cross section is equal to its resistance. So resistivity can be again once in some other way it can be defined as the resistance offered by a cube of any material of unit volume. That is resistivity. And though we will in the expression R is equal to RA by L, we can write the expression for resistivity as rho is equal to RA by L, but we cannot say resistivity changes when area of cross section changes, resistivity changes when length changes, because resistivity is the property of a material. For example, for any conductor just like copper, resistivity is a constant value. If the length of the copper rod or conductor increases, resistivity will not change because it is a constant value. So this is the relation between resistivity and resistance. So rho is equal to RA by L. So unit of R is ohm, A is meter square, L is meter. So this will get cancelled. So the SI unit of resistivity is ohm meter. Now we will think about another term that is it's another physical quantity known as current density. Current density, and current density is defined as the amount of charge flowing normal to amount of charge flowing normal through a unit area held perpendicular to the flow of charge, or current flowing per unit area perpendicular to the direction of flow of current. That is current density. So it is given by J is equal to current divided by area. So its unit, it is a vector quantity, its unit is ampere per meter square. So what is current density? It is the amount of the value of current flowing normal to a normal per unit area held perpendicular to the flow of current. And again another term is conductance. Conductance, which is the reciprocal of resistance. So conductance is a reciprocal of resistance. So its SI unit is per ohm, because the unit of resistance is ohm. So the unit of conductance is per ohm, or it is called mho, or it can be the unit can be used as Siemens. So these all are the same units of conductance per ohm, mho, Siemens. Now what is conductivity? Conductivity is a reciprocal of resistivity. Conductivity is a reciprocal of resistivity, and the SI unit of resistivity is ohm meter. So its SI unit can be written as per ohm per meter, or mho per meter, or Siemens per meter. So these are the units of conductivity. And again, so we have studied current density and conductance and conductivity. So we have studied what is resistivity. Resistivity is the property of every material. It is a constant value that depends on the nature of the material used for making that conductor. And depending on the resistivity, we can classify materials into three: conductors, insulators, and semiconductors. And conductors, as you know, that materials that conduct current so easily, and for such type of materials the conductivity is between resistivity is between 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. That is, resistivity is a small value. But for insulators, which will not allow the flow of current, that resistivity is greater than 10 raised to 4 ohm meter. For semiconductors, that conducts current partially, or whose conductance can be increased or decreased using the method of doping. That means when we add impurity to a semiconductor, its conductance can be, or conductivity can be controlled. It can be increased or decreased. For such type of materials, conductivity is between, resistivity is between 10 raised to minus 6 ohm meter to 10 raised to 4 ohm meter, in between these two values. So these are the three types of materials depending on the resistivity. Conductors, so all the metals are conductors. Insulators, plastic is an insulator. Semiconductor, germanium, silicon are the examples for semiconducting materials. The materials that do not obey Ohm's law are called non-ohmic conductors. For such type of conductors, non-ohmic conductors, that graph between I and V will not be linear. It will change. It will deviate from the original graph. As the value of V increases, the current, the increase of the current will not be linear. It may change from that normal graph. Thyristors are non-ohmic conductors. Semiconductors are non-ohmic conductors. And so we have studied what are ohmic conductors, or with the conductors which obey Ohm's law. All the conductors, all the metals are ohmic conductors because they obey this law, that is V proportional to I. But still, as the temperature increases, this rule may get violated. That means as the temperature increases, resistance will increase. So V will not be proportional to I anymore. So, but if we neglect the value, neglect the change in temperature, we can say all the conductors or the metals are ohmic conductors, but semiconductors are non-ohmic conductors which do not obey Ohm's law. Now we will study regarding the color coding of resistors. A resistor can be a particular way of color coding is given to every resistor to know its value, to denote its value on the resistor itself. So next we are going to study about the color coding of a resistor.